Action to a seminar I visited on Friday. Actually, we visited as a team. It was at Berkeley, and it was part of their electrical engineering and computer science seminar series. Very highly recommended. The specific seminar is called Physics-Inspired Machine Learning Methods, a status report on predictive chemistry and nanoscience applications by Professor Teresa Head Gordon. I think first let me explain why we went there and then the reaction. So there's two reasons why we went to this particular seminar. First, a more generic reason, I think, like we always say in this podcast, the function of a hedge fund manager is to navigate the volatile environment of wealth creation, or at least that's the way we define our mission and our function. And knowledge creation is part of that. And we have, over the years, transitioned from talking to, let's say, companies and analysts towards going much, much closer to the metal. In other words, to where the science is created, where the science transforms to products and services. So we believe that living here in Silicon Valley and navigating between particularly Stanford and Berkeley is a particularly useful time for us, use of time. And second, why we went there specifically is also we have a lot of interest in material science, in computational and predictive chemistry, particularly through our investment in Tesla, but also our investment in the synbio space, because those spaces are very, very similar in the sense that we're trying to solve problems where organic materials or materials in general are being used to solve problems such as better batteries, better conduction, better charging, better materials for the car, and everything is always driven by the our mission is fundamentally new concepts and engineering practices. So, what are the fundamentally new concepts? Well, how about first principles engineering and chemistry, or first principles engineering and life sciences? Therefore, we were very interested in this particular lecture. I want to talk about this and also a bit explain how we see the context of science and technology and investing. I think this is a good episode to kind of summarize all of that. This is not even on podcast. It's October 9th, 2022. This is Krim Delco. It's a Sunday. There's no update for the year. We're down 45.6%. The market's down 24.2%. We're underperforming by 21.4%. Fundamentally, our underperformance is driven by Tesla. Tesla's down 27% just in the last 2 weeks, driven by macro and driven by the Twitter debacle, and also, I think, also by which is related to macro, of course, the miss in the delivery numbers that will hit earnings. But more importantly, it raises questions of demand in China, which is scaring the market, and we believe that is justified. But let's jump right into this particular episode. So this is a reaction podcast to a seminar we visited at Berkeley. I mentioned it in the prelude. It's about predictive chemistry. It's about fundamentally rethinking chemistry and life sciences and physics based on using machine learning methods to better understand the behavior of particles when it comes to things like chemical reactions, or in general just behavior of particles. Let's say you want to do hydrogen combustion and you want to understand how that actually behaves, things along those lines. Just before I jump into this is also something that DeepMind is working on, which has sparked our interest. DeepMind using more of a reinforcement learning approach, and I think the professor that we visited here at Berkeley actually is using similar approaches. So before I go into the sort of the nuts and bolts of the seminar, just let me briefly explain why we do this. So we've said several times in this podcast that reading books is absolutely key for the progress of the mind of a hedge fund manager. It's not just a pastime, it is part of the business. Now, reading books is a more general way to explain, a more specific way to explain knowledge generation. So we would put into that bucket not just reading books, but let's say visiting such seminars at universities, maybe talking to scientists, going to conferences, all along that sort of frontier. I think it's just important to do that for us because we are in the knowledge creation business. Wealth creation and knowledge creation are very closely related. If you're in the wealth creation business, you better have a strategy for knowledge creation. You're not going to be able to create wealth. Now, if you are an algo trader and you want to do knowledge creation in the microsecond space, that's fine. In our case, we're not in that space. We're in the long-term space, in the long-term wealth creation space, the one that we actually as humans also feel, because it's highly correlated with products and services that typically do what Silicon Valley claims to be able to do, which is 10 times better, 10 times cheaper, in other words, disruption. So this is where we live as hedge fund managers. This is what we're trying to achieve, and this is why it's so important to go to these seminars. This is just to sort of set the stage. Now, in particular, why we went to this seminar is because it's about predictive chemistry and the sort of the idea that you have a better way to model the behavior of particles. It's an idea, it's not clear, but we've seen some progress in that space. We're using machine learning methods. To paraphrase Demis Hassabis from DeepMind, he believes that deep learning neural nets, or neural nets in general, are a better way to represent nature than math. This is the fundamental concept. This is the fundamental statement that I think summarizes very well this effort. Why are people like this professor at Berkeley, why are they spending time trying to model the behavior of particles, the behavior of things like hydrogen combustion, or all those kinds of particularly interactions between molecules? Why are they doing that using neural nets? Well, because it might be a better way to represent the behavior of these particles. What are these neural nets really doing? They're trying to use data, they're using data and then having algorithms adjust to a function or evolve a function that then explains the behavior of these types of, let's say, the molecules. So we don't know the function. We don't have a way to express the behavior of electrons, valence electrons in a chemical reaction, for example. We don't have a good model. We have mathematical approximations, differential equations, where we have a dynamic system that evolves through time and somehow tries to get us from A to B, tries to explain how, let's say, a bunch of molecules and associated valence electrons will behave. This is the sort of state-of-the-art approach before the entrance of neural nets. The neural nets, according to Demis Hassabis, seem to have a better way to express this dynamic process. This is sort of the idea, and we are very encouraged about this. And we also believe that, for example, Tesla could be using some of their AI approach in material science and let's say generally in the material science problem space that they live in, which is particularly batteries, charging technology, and the solar side of things, where they have a solar panel, evolution of solar panels and those sort of things. So the energy space is very much a material science space, and therefore we could see good synergies there. Now, let me specifically talk a little bit about this seminar also. Another thing, a little bit, another sort of related aspect, which is kind of the political side of things. We were a little bit disappointed about the seminar because first, we believe that people like this professor coming from the chemistry physics side seem to struggle a little bit with the neural net machine learning side of things. It seems that it is not necessarily that this particular disciplines don't commute. In other words, you can go from CompSci into physics and chemistry, but not necessarily from physics and chemistry into CompSci. There were two instances where I felt like this particular professor wasn't very genuine. One, she was talking about messaging networks and developed a sort of her own network, neural net, to explain the behavior of particles. And in essence, she was talking about graph neural nets. So something that on the CompSci side is very common, that people openly discuss, also borrow from, let's say, open source libraries. And I am sure also this lady is doing that, but she wasn't very genuine about it. She was kind of trying to disguise this as sort of her innovation, when in fact, I think the culture in CompSci is that there's very little my innovation type stuff. I mean, if you listen to, let's say, a lecture by DeepMind, despite of all the success that DeepMind had as a company, they're borrowing a lot of technology from the open source community and from models from academia. Same with Tesla. They don't necessarily claim that they develop their own, let's say, graph neural net. They do adjust things, and that's where they usually, where the I comes in, where they would say things like, well, we used, let's say, model X, and then tweaked it for our purposes. I think DeepMind, when they discussed the AlphaFold technology, spoke about the reinforcement learning side of things, and then using a sort of a specific Monte Carlo search that I believe is more geared towards their own purposes. So of course there is the I, there is the this is what I did kind of thing, but usually it's within the context of what else is out there, what else is available, because again, CompSci in general, the computer, the computer landscape, the software landscape is a very open source driven landscape across the stack, even now with RISC-V, also down to the ISA level. So this is one thing that I thought the lady wasn't particularly genuine. Another thing was in the model itself, so in the approach or the architecture of the model. Again, the professor spoke about something that reminds us very much of sort of the state-of-the-art generative models that, let's say, are used in natural language processing or in image detection, where you take an image and then you hide certain parts of the image and you want to predict the rest of the image. So those kinds of approaches, again, the lady was kind of trying to sell this as sort of her innovation, and then she was corrected by some parts of the audience. She was a bit terse about this, and therefore I think the discussion just wasn't as open as I would have hoped to be. I think the reason why this might be happening, this is not my conjecture, is that this particular professor was also bragging about all the funding that she's getting from National Lab Sciences and foundations and all of that kind of stuff. And this is a critique that I have as an observer. I see that the academic landscape is very much driven by things like grants and also all those sort of things, which in my view are actually detrimental to the progress of science. Because we saw this with this whole COVID situation, that we have too much concentrated power in Washington in terms of funding, in terms of developing science through the government, which on the one hand is, in our view, a waste of taxpayer money, but much more importantly, also it crowds out science. It takes a lot of intelligent, capable people and sort of squeezes them into a more government-driven, top-down, centrally planned science complex, an industrial science complex that I think President Eisenhower also mentioned when he spoke about the industrial military complex. Those are the kinds of things that we're aware of as observers in this particular space, and we would hope that this could change. I don't know how. Of course, we've seen some breakthroughs out of that corset, if you want, particularly in the sort of CompSci community, a bit less in the physics community. I've seen that also when we did work on quantum computation. The government gets involved very quickly. The government, again, spends a lot of money, but also crowds out knowledge creation, crowds out sort of the market-driven, more flexible approach in knowledge creation. And this is not a good thing. This is just an observation. We don't have a solution for that, but we just wanted to mention this. So to summarize, reaction podcast to a seminar we visited last Friday at Berkeley. A very good, by the way, very good program that Berkeley has. Shout out to Berkeley for that. In this particular case, the presentation was a little bit disappointing. We mentioned that the combination of CompSci and chemistry and physics and biology seems to work one way, but not necessarily the other way. It doesn't commute. So CompSci people can go into their space, but not vice versa. And that has to do with, I think, the lack of culture. This is a cultural thing, certainly not a matter of intelligence or anything, but the culture, the CompSci community is much more open source driven, much more dynamic, open for ideas, absolutely used to borrowing from each other and all that. Versus in the physics and chemistry and also biology community, it's a little bit more, I did this in my lab and all that kind of stuff, because these people depend on government funding, and that there's this crowding out of natural progress and more organic market-driven research. Nevertheless, we at Orange Capital Partners are very happy to have these opportunities to go visit all these seminars. We live in Silicon Valley, so we're mainly navigating between Stanford and Berkeley, but we're very open to go to other places also around the world, actually, that offer opportunities for learning. Thank you.